Right, in this chapter we're going to be studying three-dimensional solids, and the different kinds of three-dimensional solids. So what we need to do first, before we look at any kinds, is you need to think of these as floating in space, any three-dimensional solid, not sitting on a table, because if you do that, then you're more likely to make an error when we come to start talking about bases, because you'll start thinking about, well, if it's sitting on the table, that part that's sitting on the table is its base. And it's not. A lot of them will have more than one base. So we need to think about the shapes as floating in space that you can rotate and move around. All right, our first shape that we're going to look at is a cylinder. A cylinder has two bases. Those bases are right there on that cylinder, right here, and right here on this cylinder. So those bases are what kind of shapes? They are circles. That's correct. Cylinder has two bases and they are circles. There are two different kinds of cylinders here. We have a right cylinder, and the reason it's called a right cylinder, when you drop the axis, which is the line that runs through the center of the geometric solid, and it hits one of the two, hits the base, one of the bases, it forms a right angle. This is a right cylinder. This is the kind of cylinder that's probably very common to you. You see it at lunch or at your home, right? An example would be, what's an everyday example of a cylinder? Yeah, pop can. But notice, it happens also up here. There's a right angle there because there are two bases in a cylinder. This is called an oblique cylinder. It's an oblique cylinder because when the axis hits the base, you have one acute and one obtuse angle formed. Oblique just means it's leaning. That's all it means. Now when we get into surface area and volume, we will just exclusively be working with the right cylinder. But there are two different kinds of cylinder. When you see oblique in anything, that means it's leaning. Oblique prism, oblique pyramid. So those are the cylinders. Cones. Just like with our cylinders, there are two different kinds of cones. Cones and cylinders are related. How are they similar? What's the base of a cone? Well, first, yes. A cone has one base. It has one base, and the base is a circle. So just like a cylinder has a circular base, when we get into volume, you'll see that the volume of a cone is just the same as the volume of a cylinder, except you multiply it by 1/3. What that means is I could take any cylinder that has the same size base, or I can take any cone that has the same size base as a cylinder and put that cone inside the cylinder. And its volume will be 1/3 of that cylinder. We'll get to that. Right cone, evidently just like with the cylinder, if you drop the axis, where it hits the base, it forms a right angle. An oblique, it's leaning. One base, and that base is a circle in a cone. And the next kind is a sphere. It has no bases. It has, it's a ball, and it's got a center. If you go out from the center to the edge, there's a radius. This has the most unusual, I think, in my opinion, the most unusual volume formula. It's like 4/3 pi r cubed, I think, for the volume of a sphere. That's really, it has a diameter, radius, center. It's not made up. How is this one different than all the other ones? Well, if we look at all the other shapes, cones, cylinders, and when we get to the other ones, all of those are made up, have at least one part that is a two-dimensional shape, right? For cylinders and cones, that two-dimensional shape is a circle. If I cut this in half, then I'll have a couple circles, but there's no flat side to it anywhere. All right. So the first three that we looked at are all ones that are unique. They're in their own category. They're not made up of shapes exclusively. Now we're going to get into the kinds of three-dimensional objects that are made up exclusively of two-dimensional shapes. All of these, now don't put this picture down yet and all this, just look at that word. That is polyhedron. The rest of the shapes that we going to talk about are all what we would call polyhedra. That's the plural form. A polyhedron is a closed three-dimensional figure made up of polygons. Now, do you remember when we talked about polygons? There are a bunch of different shapes that are polygons. Triangles, rectangles, squares, hexagon, heptagon, octagon, nonagon, decagon, 12gon, 20gon. Those are all polygons, depending on how many sides it has. Well, what we're going to talk about now, they're all polyhedra. The first three that we mentioned, spheres, cones, and cylinders, are not polyhedra because they didn't have, all their sides were not made up of two-dimensional shapes. Each one of these faces that I look at is a shape. Here I got rectangles and pentagons. All right. First polyhedron we're going to talk about is this one. It's a prism. A prism has two bases and its faces are, well, what shape? The faces are rectangles. Very good. I forgot the word R. Faces are rectangles. We can see that if I outline one of them. Let me outline one of them in green. Here's one of the faces right there. That's a face, that's a rectangle. So in any prism, if it's not a base, it's a face, and those faces are rectangles. That's how I know it's a prism. Well, the thing about the bases, and let me outline the base in yellow. In yellow, not green. There we go. In a prism has two bases, and they are congruent. That's the word I forgot in here. It has two congruent bases. That means they're identical to one another. They're the same size and the same shape. I have a pentagon here and a pentagon in the back, right back here. There are my bases. They're congruent. That's how I know this is a prism. It's got two congruent bases, two shapes that are exactly the same, and they're parallel to one another. They'll never intersect. That's how I know this is a prism. And then I look at all the sides, and all the sides are rectangles. So, two bases, and then the other sides are all rectangles. I know I have a prism. Well, we also have some other words here that we need to look at. Edge. Here's an edge right here. What would you say, what is an edge? Can somebody give me like just a working definition? It would be where what meet? The sides, right? So it's where the faces meet. That's an edge. An edge is where the faces meet. That's what an edge is. It's where the faces meet. A vertex, this is a vertex right here. The vertex is the pointy part where the edges meet. The face, that's one of the sides that's not a base. Now, one other thing we're going to add is in a prism, it has two congruent bases, and the faces are rectangles, but the prism is also named for the shape of the base. It's named for the shape of the base. What is this shape? It's a pentagon. So this is called a pentagonal prism. This is a pentagonal prism. because its bases are pentagons. So how would you write that out? You take the name of the shape and add AL at the end, with the exception of triangle and rectangle. So you get above four-sided, then you get pentagonal, hexagonal, heptagonal, octagonal, nonagonal, decagonal, up to 10-sided decagonal. After that, 11 gon, you're just on the 11-gonal, 12-gonal. The next kind of shape we're going to look at, this is also a polyhedron, is a pyramid. Now look at the difference between a pyramid and a prism. What's the most obvious difference? How many bases does this have? 1. So a pyramid has one base. Now I made a mistake right here. That should be base with a capital B. Does anybody know the difference of when we write base with the lowercase b and capital B? What's the difference? What if it's floating and I rotate it up? Lowercase b base means it's a line segment, like the base of a triangle is a line. A capital B means it's a shape. It's a base of a three-dimensional object, so it's an entire shape, a triangle, a rectangle, a pentagon. So that's the difference. Okay, in a pyramid, we have one base. And what about the sides? Its faces. In a pyramid, the faces are what? Well, what is this? What is that? A triangle, right. So the faces are triangles. We have one base and the faces are triangles. That's how we know we have a pyramid. Also, just like the prism, they are named for the shape of the base. What shape is here at the base? A triangle. So this would be what kind of pyramid? A triangular pyramid. That's right. So this one is a triangular pyramid, because the base is also a triangle, just like the faces. Which means that there are other kinds, right? Here's a different kind. What kind of pyramid would that be? Well, look at the base. What is that shape right there? That's right. So it would be a rectangular, because the base is a rectangle. This would be a rectangular pyramid. And that one would be pentagonal, right? Good. Pentagonal pyramid. So we look at the base, see what kind of shape it is. That gives us the name for both prism and pyramid. Then you just have to write prism or pyramid. If it's got two bases, it's a prism. If it's got one base and the sides are triangles, it's a pyramid. All right, prisms and pyramids, we talked a lot about their bases, but it also has lateral faces and lateral edges. Those are the other shapes. In this rectangular prism right here, the lateral faces are all the ones on the sides, whether it's the front or the back or the side here. Here, it's all my triangles in the pyramid. Those are all my lateral. So, what could I call this? Well, we'll get to that. Lateral edges will be everything I put. I want to do it in yellow, not highlighter yellow. Here are all my lateral edges. What could be like just a working definition we use? What are all the lateral stuff? It's the stuff on the sides, right? That's a good word. That's a working definition we'll go with. All the lateral stuff, if we talk about a lateral face or a lateral, it's on the side of it. If you're looking at it straight, it wouldn't be the top or the bottom. Stuff on the sides. That's what lateral is. Here's one thing you're going to have to do tonight. You're going to be given, don't write this stuff down, we'll just go through it together. You're going to be given a shape and they're going to ask you some questions about this. Well, first of all, what is this shape? This is a rectangular prism. Name a pair of bases. This should be capital B bases. Very good. So, right. A, B, C, D on the top. Right. So we could go A, B, C, D right there. And what? And E, F, G, H on the bottom. Very good. Right there. Those two rectangles. But how many, potentially, how many do I have? Yeah, I have what? 3 sets of 2, right? I could have gone A, D, F, E, and B, C, H, G. Or I could have done the sides. A, B, G, E, and D, C, H, F. That's up to you. Just depending on... Now, the rectangular prism is the only one that you could pick which bases you're going to have. If it's a hexagonal prism, the top and the 2 bases are hexagons. You don't have any choice. You just have to pick those. All right. How about a pair of parallel edges? Those are 2 edges that'll never touch. Well, you have lots of different choices. I'm sorry? AE and BG. Yep. Yeah, if you pick this one, he picked this one. You could have picked DF. You could have picked CH. There's lots of them. If you could have gone AB, and then you could have gone CD or FH or EG. Yeah, there are lots of different ones. Just make sure you identify them as line segments. How about a pair of intersecting edges? Say that again. AE and AB? Sure. How do I know they intersect? They're going to have the same letter. That's where the vertex is going to be. Could have gone AE and AD, AE and EF. Yeah, just like the last one, lots of different ones. Skip that. We're not going to do that. How about a pair of intersecting faces? So these will be 2 faces that touch to form an edge, right? They will form an edge. So you said A, B, C, D, and what other one? So A, B, C, D. And what? A, D, F, E, right there in the front. Good. So that's one thing we'll have to do today, or you'll have to do tonight. They'll give you a shape and then ask you questions about that shape. The other thing you'll have to do is draw. I do not expect them to be works of art. You've seen my drawings. They're not good, so I don't expect yours to be that good. But before you start drawing, you need to know what you need to have. You're going to draw a prism. So a prism has 2 bases, and what are its sides are what? What shape? Are what? Rectangles. So I have 2 bases and the sides are rectangles, and what shape are my bases? They're triangles. Anybody want to come up and draw it? Okay then. Here's how I draw all my prisms. I take the shape, put the other one just behind it, and just connect the points. Like that. That is a triangular prism. Both bases are triangles, and by connecting the lines, all the sides are rectangles. You can draw any prism that way. If it's a pyramid, what you do is draw the base, if it's a triangular pyramid, and then connect all the points like that. That's about a good drawing, but you know, it works. And I told you it didn't have to be good. Just have to be there. A right hexagonal prism. All right, that means it's going to go vertically, not horizontally, so it's going to go up and down, a right hexagonal prism. So I have a prism, so that means I have two bases, and my sides are rectangles, and my base is a hexagon. All right, well, I can cheat a little bit. Get my hexagon. There's my hexagon. Do it like that. That's a right hexagonal prism. Okay? You say so? Actually, might have been a little better if I offset. Well, I can't offset it, otherwise it won't be a right one. All right. So you're going to have to identify parts, draw, or if you're given the shape, you'll have to tell what it is. 423. Now the homework starts on the bottom of page 423. 423 to 425. 2 to 38 evens.